Okay, so let's go ahead and do part 2. More completing the square. We'll start off with another example right here. Like yesterday, I think we did this one. So I just want to do one more example to warm up. So the thing you need to remember when you're completing a square is that you want to have a perfect square over here. And right now there's a C right there, and it's probably the wrong number. So what we're going to do is move that wrong number over to the other side for the time being. So we subtract 1 here, subtract 1 here, and then we have the setup we want. The setup that we want to figure out. So that would give us x squared minus 10x. And then what we want to do is add something to make this a perfect square. And then over here we have the left side, or the right side, we have the same square. We have to add the same number to both sides of the equal sign. So the trick now was like those first 3 problems you did on the study guide. We need to find the C term. And it's pretty easy to do because all you need to do is divide this one by 2 and then square it. And so this gives us a 5, right? Put the 5 right here and then we square that, right? So the number that goes here is a 25. That means you need a 25 over here. And so what it means then is that we get an x minus 5. Alright. Count your blessings. Alright, 24. Does this sort of make sense so far what I'm doing? Alright, if you want you can copy down this example for your study guide, but we're going to do a couple of these in just a moment. So once you have the perfect square, we'll use the square root method. The idea is to take the square root now on both sides of the equal sign. So I want to take a square root here and a square root here. And because I'm solving for x, I get a plus or minus here. And remember, the square is the inverse operation of the square root, so these cancel. And so we get simply x minus 5 right here is equal to plus or minus square root 24. Okay? And so then finally we can move the 5 over by adding 5. And this gives us x is equal to 5 plus or minus the square root of 24. Now, we could probably simplify that. You guys see some perfect squares in there? Yeah, 4 and 6, right? If you take the square root of 4 and the square root of 6, we could write this as this number would become a 2, right? So we could write this as 2 square root 6. And so that's how we would work out this problem. Okay. Now, I think I'll stop the video for a moment. Okay, so let's take a look at number 4. See if you're doing this right. Okay, so the first step is to move the 6 over there, right? So you're going to end up with an x squared minus 10x. And then you're going to have a plus something is equal to, well, once you move this 6, it's going to be negative 6, right? Negative 6. And then you're going to add the same something over here. This is very similar to the previous problem, right? That we just did. If you divide this one by 2, you get 5. And then if you square that, you get 25. So you're going to get x minus 5. Is this the same problem?
Almost. No.
Almost. My goodness. Oh, okay. So almost the same problem then. Okay, so
I just said it had a 1.
6 plus. And so we got to add a 25 over here. Because you have a 25 here and a 25 here. Okay, so now we simplify this, right? This becomes No, it becomes a 19, right?
19 chicken wings.
19. 19 chicken wings. That becomes a 19, right? And then a square root here, and a square root here. So this gives me x minus 5 is equal to plus or minus the square root of 19. Okay, and now I can move the 5 over by adding. So these take a little bit of work. Okay. All right. Now, these guys right here with a coefficient out in front that's different from 1, they involve an extra step, because when we're completing the square, we want that to be a 1. Otherwise, our dividing trick doesn't work. You know how we divided by 2? That only works if there's a 1 here. Okay, things are a little bit more complicated if there's another number. So we have to modify our completing the square when we have one of those. So that's the one I want to show you next, is how to deal with that. Okay, so let's deal with one of those. Whoops, hold up. So once again, this will be similar to your study guide, I think. Alright, so anytime there's a number out in front, you have to get rid of it. Okay? You have to get rid of it. Well, you have to get rid of it, though, in a legal sense. In a mathematical sense. That means divide by that number everywhere. And so you just divide by 2 everywhere. That gets rid of the 2. And so now this simplifies to x squared plus 4x plus 7 equals 0. Because 0 divided by 2 is still 0. Once you get rid of that number now, then the problem is identical to the one we just did. So I'll just go through the steps here real quickly. What you want to do first of all is move the 7 over there. So that gives us x squared plus 4x plus, we're going to add in some number over here because we're going to want a perfect square. And once we move that 7 over there, it's going to be a negative 7, right? And we add the same square here. Now to figure out what's in that square, we divide this one by 2 and we get 2. And then you square it. So that gives us a 4. And we have a 4 over here. Again, hopefully you're becoming familiar with these steps. And that's all this section is. It's just a bunch of sequence of steps, and if you learn the steps, kind of like a dance, you should be able to do this problem with no problem. Okay, so we found out the number that's missing to make this a perfect square, and now we just need to make it a perfect square. And we're going to use this number here, x plus 2. Now you can always sort of check quickly if you have this correct, because your C number is always sitting right here. So that should be there. And 2 squared is 4. So that kind of gives you a little confirmation that you're doing things right. Negative 7 plus 4 is negative 3 this time. And notice this time when we take the square root, we're going to have a complex number because of that negative, right? Let me just back up a little bit. And I want to take that off of there. Alright. Negative 3. So when we take the square root this time, square root on this side, we're going to get x plus 2 is equal to plus or minus, and I want to rewrite this as a square root of negative 1 times the square root of 3. Okay, because on a few of these problems you will get some imaginary numbers or complex numbers. So I'm going to go down to here, so where we have some white clean space. So this gives us x plus 2. Now this of course is I, right? So we're going to say this is equal to plus or minus I times the square root of 3. And I think we'll just go one more step. We'll just move this 2 over by subtracting 2. And so we get x is equal to negative 2 plus or minus I times the square root of 3. We'll leave our answer like that. Okay, with that being said, I would like you to go ahead and do number 5 now. Take a moment and do number 5 on your study guide. Once again, I'll pause here. Okay, so I'm going to talk to you about vertex form. And you'll notice way back when we did section 1.1, we talked about quadratic formulas and or quadratic equations, and we had parabolas and standard form. And then we started looking at vertex form. And it's in this section that we learn how to change from standard form and to transform that into vertex form. And we do that by completing the square. You'll notice there's a perfect square in here in vertex form. So the whole idea is to complete the square. So it's just a slightly different problem that we've been doing. But let's go ahead and look into that now. Okay. I'll come back to that problem. I don't know if I want to do that one. These are some practice problems. I think we just practiced some already. Vertex form. So there's our vertex. Huh? Oh, I should erase this. Hang on. Sorry. So we work it out just as we did before. We're still going to move the C term over and things like that. So I'll show you the sequence of steps here, and then we'll do the rest of our study guide, I think, or most of it. Okay, so the only difference in this problem, as you might imagine, let's back up here just a second. All right. All right. The only difference is that we don't have a 0 over here now. In the previous problems, we all had a 0. Now you have a y in there, so things are just a little bit different. So we still move the c term over to the other side. That needs to go over here because right now it's not a perfect square. Okay, so we start out by subtracting the 22. And this time, though, we have a y sitting here. So that's going to change things just a little bit. So we have y minus 22 is equal to, well, let me put some space in there because we're going to add a box in there, right? We're going to add a box right here is equal to x squared minus 10x, and we want to determine now what number it is that makes this a perfect square, because what we'd like is a perfect square here. So notice the only difference is that we have a y sitting over here now. Okay, so our search for that number is the same as before. We're going to divide that one by 2. We'll get 5, and then we square it, right? And so we get a 25 here and a 25 over here. So let's take a look now. This becomes y plus 3. You see? That combines. Oh, by the way, it's not a bad idea if you want to copy this and have it as your notes or whatever. But what we have over here now is x minus 5. Everyone understand why it's minus? Because we have a minus sitting right there. So to get the minus 10, we're going to have a minus in it. Okay, so now all you do is solve for y. And it will be in vertex form. So you subtract 3 here, subtract 3 here. And this equation now is in what we call vertex form. Y is equal to x minus 5 squared minus 3. And now that should look like vertex form. Remember, the advantage of vertex form is that you could then find the vertex very easily, right? If someone asked you what the vertex was, remember how to do it? Dx is a little tricky. You have to switch the sign, right? So that's positive 5. And then the y coordinate is negative 3. So you can find the vertex really fast. Okay? So in this problem, we changed this from standard form. That's standard form. And we wrote it in vertex form, which is what we got right there. Okay. And again, we then were able to find the vertex quickly. Okay. What I would recommend that you do now is number 7, 8, and 9 on your study guide. And I'm going to give you about 10 minutes to do those 3. And I'll pause this again, and then I'll cover one last type of problem. Okay, so let me talk briefly about number 10. You have an example that's kind of worked out, and it's a little bit messy. What they did is they multiplied it all out. Huh? Oh, sorry. Yeah, let me erase the board real quick. It's kind of messy, so you got to multiply it all out first. You get the equation into standard form, and then they completed the square. Well, so this is kind of ugly, you know? And so sometimes the idea is not to make math more complicated. Darn it. What you're after is the vertex. So you'll notice that the math here looks quite ugly, especially right about here. We have this big ugly mess. What I would recommend on this one, remember there's 2 ways to find the vertex, right? Pay attention. There's 2 ways to find the vertex. We could complete this ugliness into vertex form. It's not too hard. We could do it. That's what they did here. But remember, if we want to find the vertex, we could also say x is equal to negative b over 2a. And had we taken that route, we might have gone a lot faster, because this right here is your b, this is your a, right? And so you could have gotten the x coordinate really fast, and it would be probably faster than completing the square. So you would have written this as like negative 200 over 2 times whatever a is. Well, a is negative 10, and so we would have gotten negative 200 over 20, and a negative divided by a negative is a positive, and I think this would have been just 10, right? And see, notice that the x coordinate is the same, okay? And then all we needed to do was to find the revenue was to take r, plug in 10, and find out what the y coordinate would have been. Well, we would have had negative 10 times 10 squared plus 200 times 10, and then plus 15,000. And I'm sure if you do that in your calculator, you end up with 16,000. Now, one question remains: is this a maximum or a minimum? Now remember, because of this negative right here in front, that means the parabola opens down. Well, if the parabola opens down, then it's going to have a highest point, and that makes this a maximum. So that's why we could say this is a maximum. Make sense? Okay, so you might decide on this particular problem when you get to it that you might use the old method of finding the vertex for standard form. I'll leave that up to you, but that comes up on number 10. So what I'd like you to do now, I think, let me go back to my PowerPoint, make sure I haven't skipped over anything. There's a baseball problem. Well, this is just a problem where you can end up doing the you want to find the maximum height. So there's two ways you can do it. You can do the vertex method where you have x is equal to negative b over 2a, or you can transfer this into vertex form where you have something like a times x minus h squared plus or minus k here. You can find the vertex straight away. So it makes no difference to me which method you use, this one or this one. I'll let you choose. But your maximum height is going to be the y coordinate. This will be your maximum. Okay? Alright, well, I think you can get going.